Welcome to AI Frontiers, the podcast dedicated to exploring the latest advances in artificial intelligence and machine learning. In today's special episode, titled, Beyond the Point, Machine Learning's New Frontiers, we feature 17 pioneering research papers released on May 23, 2025. These works collectively highlight the cutting edge of machine learning, with a particular emphasis on distributional, efficient, and aligned learning. Over the course of this episode, listeners will discover breakthrough directions in both theoretical and applied machine learning, tracing the evolution of the field as it adapts to ever more complex data and application domains. This session is designed to provide both a broad survey and a deep analysis of academic progress, making it accessible to practitioners, researchers, students, and anyone with a keen interest in the scientific foundations and future of AI. Here is what to expect in today's deep dive. The episode will thoroughly unpack 17 impactful machine learning papers, all published on a single research day. 6 dominant research themes will be explored, each illustrated with concrete examples and key breakthroughs. The discussion will emphasize practical implications and spotlight seminal works that are actively shaping the direction of the field. Methodologies will be dissected to illuminate the technical underpinnings of current trends, and the future trajectory of AI research will be mapped. The episode concludes with a synthesis of insights, providing an expert-driven overview of the state-of-the-art and a preview of what lies ahead for machine learning and artificial intelligence. Machine learning stands as the beating heart of artificial intelligence. It empowers systems to make predictions and decisions directly from data, fundamentally transforming how scientific, medical, and industrial challenges are addressed. Unlike traditional programming approaches that rely on explicit, handcrafted rules, machine learning focuses on uncovering patterns that enable systems to adapt to new inputs and situations. This paradigm shift is central to the design and operation of modern AI systems, influencing interdisciplinary innovation across domains such as recommendation engines, autonomous vehicles, voice assistants, and scientific modeling. The pace and vibrancy of research activity in the cs.LG category on the arXiv preprint server exemplify the rapid evolution and central importance of machine learning within the broader landscape of computer science. The first major research theme is, From Points to Populations, Distributional Representation Learning. This theme is exemplified by the work of Fishman and colleagues, who introduced Generative Distribution Embeddings, or GDEs. These methods are designed to encode and model whole distributions rather than isolated data samples. Such an approach is crucial for domains where the unit of analysis is inherently a population, such as groups of cells in biology, ensembles of molecules in chemistry, or patient cohorts in medicine. By enabling population-level insights and predictions, distributional representation learning moves machine learning toward a richer and more nuanced understanding of complex, real-world data structures. This shift underpins advances in scientific discovery and practical deployment across diverse application areas. The second research theme focuses on training efficiency and optimization, aiming for faster, leaner, and smarter machine learning systems. Key contributions include the development of efficient neural network architectures, such as Kolmogorov-Arnold networks, which significantly accelerate the training process for multi-layer perceptrons. Advances in quantization techniques are also analyzed, particularly for their impact on deploying models in edge environments with limited computational resources. Recent work provides a finite sample analysis of the straight-through estimator, clarifying its theoretical limits and strengths. Collectively, these innovations center on improving speed, memory efficiency, and the practical deployability of machine learning models, thereby increasing accessibility and utility in resource-constrained settings. The third theme encompasses alignment, safety, and robustness in large language models. Research by Wolf and collaborators investigates reward model overoptimization within reinforcement learning from human feedback, or RLHF. This line of work develops and evaluates techniques to ensure that AI systems behave in ways that align with human intentions. Challenges such as reward hacking and benchmark contamination are addressed, with particular emphasis on the design of iterated RLHF pipelines that yield stable and generalizable models. The intersection of ethical and technical rigor remains central, as the deployment of large language models in sensitive environments demands systems that are not only powerful but also safe, reliable, and consistent with societal values. Theme 4 highlights the extension of transfer learning, continual adaptation, and theoretical frameworks within machine learning. Foundation models, historically successful in domains such as vision and language, are now being extended to tabular and mixed modality data, broadening their applicability. Dynamic memory frameworks are developed to address the challenges of continual and online learning, preventing catastrophic forgetting as models encounter streaming or evolving data. The work of GU and colleagues reveals phase transitions in knowledge acquisition, using theoretical tools from biology and information theory to interpret these phenomena. As a result, machine learning systems are becoming more adaptive, resilient, and capable of thriving in dynamic environments. Key findings across the reviewed papers reflect significant progress in multiple dimensions of machine learning. Generative Distribution Embeddings, advanced by Fishman and colleagues, are redefining how populations and distributions are modeled, particularly in scientific and medical contexts. Finite sample theory offers new clarity on the strengths and limitations of quantization, informing the deployment of efficient models. Wolf et al. Demonstrate that overoptimization in RLHF decreases with successive iterations but eventually plateaus, highlighting the importance of pipeline design. GU et al. Challenge prevailing scaling assumptions by uncovering phase transitions in knowledge acquisition. Additionally, negative-aware supervised learning is shown to match or exceed reinforcement learning for certain reasoning tasks, underscoring the evolving interplay between learning paradigms. The methodologies underlying these advances are both diverse and robust. Distributional learning, which employs specialized encoders and generators, allows for the capture of complex population-level patterns. Architectural refinements, such as those based on Kolmogorov-Arnold networks, facilitate more efficient optimization and convergence. Iterative and online learning frameworks are deployed to mitigate catastrophic forgetting and support continual adaptation. Reinforcement learning from human feedback is used to enhance alignment between models and human values, while information theoretic analysis provides a rigorous lens through which phase transitions and scaling laws are revealed. Each methodology brings unique strengths and challenges, contributing to a more comprehensive and resilient machine learning ecosystem. A closer look at the first seminal paper, Generative Distribution Embeddings by Fishman et al., reveals a pivotal shift in machine learning practice. This work models entire distributions rather than individual data points, addressing scientific problems where reasoning at the population level is essential. The proposed framework employs an encoder that processes sets of samples from input distributions, compressing them into latent representations. A conditional generator, such as a conditional generative adversarial network or conditional variational autoencoder, then reconstructs the full input distribution. The latent space is aligned with Wasserstein distances, ensuring that distances between representations reflect true distributional differences. The method achieves state-of-the-art results on both biological and synthetic benchmarks, establishing a foundation for future analysis of scientific and medical data. The impact of this approach is significant, enabling new forms of prediction and mechanistic insight. The second seminal paper, Reward Model Overoptimization in Iterated RLHF, by Wolf and colleagues, delivers the first systematic analysis of overoptimization in reinforcement learning from human feedback pipelines. By leveraging the controlled alpaca farm benchmark, the study demonstrates that overoptimization diminishes with additional RLHF iterations, as reward models improve their approximation of human preferences. However, diminishing returns are observed, signaling a plateau in performance gains. Policy initialization strategies are shown to affect both the robustness and the degree of improvement attainable in each round. The empirical insights provided by this research inform best practices for constructing safer, more generalizable large language model alignment pipelines. This work sets new standards for evaluating and improving human-in-the-loop training procedures. The third seminal paper, Phase Transitions in Knowledge Acquisition, by GU et al., investigates how abrupt jumps in knowledge learning occur as both model size and data composition are varied. Using an information theoretic framework, The study predicts and empirically verifies critical thresholds at which models transition from memorizing very little to acquiring substantial knowledge. This discovery has a profound impact on data curation and model training strategies, notably demonstrating that more data or larger models do not always yield incremental improvement. Instead, the interplay between data quality and model capacity can drive sudden, nonlinear gains in knowledge. The findings advance the understanding of scaling laws and provide practical guidelines for optimizing training regimes in modern large language models. Looking to the future, several directions are poised to shape the next generation of machine learning research. There is an increasing focus on integrating distributional and population-level learning across new scientific and engineering domains. The blending of supervised and reinforcement learning signals is enabling the development of self-improving models that transcend traditional paradigm boundaries. A deeper study of scaling, phase transitions, and information allocation is anticipated, with the aim of unlocking the full potential of large, heterogeneous datasets. The advancement of efficient, quantized models for deployment in edge and low-resource environments remains a priority, as does the commitment to robust, transparent, and ethically aligned AI systems. Together, these trends promise to drive both technical innovation and responsible progress. Behind this episode is a synthesis process powered by advanced AI tools and expert human review. Research was synthesized using GPT-4.1 from OpenAI, ensuring a comprehensive and up-to-date overview of the latest developments. Google text-to-speech technology provides the voice narration, while Google tools contribute to visual and image synthesis. All content has been reviewed by human experts for clarity and accuracy, though some oversights may persist. Full references are provided for all sources discussed. This collaborative approach ensures that the episode delivers accessible, rigorously vetted research summaries to a broad audience. In this podcast, the latest breakthroughs in computer science and AI are brought straight from the arXiv preprint server. Topics span from neural networks to quantum computing, with a focus on simplifying complex research so listeners can stay ahead of the curve. Whether a developer, researcher, or technology enthusiast, AI Frontiers delivers daily updates to keep the community informed and engaged. Thank you for joining this deep dive into the world of machine learning research. If this episode was valuable, consider subscribing for daily insights. More cutting-edge AI developments await in the next episode. Disclaimer. This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.